Hello everyone. So in the previous video, we left at this particular position where we created a train X and train Y lists. Now in this video, we're going to train a model. So let's get started. So first, what I'll do, I'll just reset the default graph because I want to reset any underlying graph data will be there, so it must be get erased. For that, I use df.reset underscore default underscore graph. So this is for resetting the graphs. Now I will be building my neural network. So in order to build the neural network, as you've seen, I've imported the df.tflearn library, which increases the process of experimentation. Equals to sign. So shape will be none, capital none. Length will be train underscore x 0 net equals df on dot fully underscore connected net 10 net equals to df dot fully score connected. Again, I want one more layer of this. Again, repeating. This is basically you're creating your own neural network, and these are at each line you are creating your own neural network layer. Dot fully connected net comma length of train underscore y 0 activation. We'll be using softmax activation. You can even use any other type of activation. There is a lot of type of this ReLU activation also available. Let me just use but softmax. So df.learn dot regression net. Now the next task is defining the model and setting up the tensor boards. For that, model df dot tnn net tensor board dir will be equals to df learn underscore logs. These are basically recording your model's performance at each step, so it will just log it record into the tflearn underscore logs. Now finally we have set up model. Now we need to train that model by fitting the data into it. So we'll use the number of epochs also is the number of times that the model will be use our data during the training. So for that, model dot fit train underscore x train underscore y and epochs, let me use 1000 because the more the number of epochs you use, more accuracy your model is going to have, because more amount of training it will learn. Show metric equals to true. It will give us the metrics also at each state, what is the accuracy and all. Now I will save the model. I'll save it model dot tf learn. So now let me just write the comments for each step so that you are able to grasp it in a more better way. So I wrote it. Now let me run the statement. Okay, TensorFlow has not reset. Okay, let me just wait. Okay, we just come to know that this function is deprecated. So instead of this, we need to use this function .compile.v1.reset. This is the latest version. The older version has been deprecated. So yeah, let's run the again. Okay, so model started training. So you can even see the number of epochs it took. It's 35, 36. It will run up to 1000. 48, 49, 50, 52. So you can see, and you can even see the accuracy and the iteration. These are all the metrics that you have just enabled by show underscore metric equals true. So You can even see it. You can even see the training loss. So you can see the training loss is fluctuating. It might sometimes go high, it might sometimes go low, but as the more number of epochs gets completed, so that obviously the total loss going to decrease. And we are using Adam optimizer. So by default, it is Adam optimizer. You can even, if you want new optimizer, you can have an optimizer argument you can pass in the model.fit, and you can have your own. There are various optimizers available. So by default, it uses Adam optimizer. So it has 120 epochs. Now you can see from 1.6 the loss has been come down to 0.546 respectively. Now since this process will take some time, so let me just pause the video until the 1000 epochs has been achieved. I'll resume back the video because it will take some time. Okay. So guys, you have resumed back and it has finally achieved the 1000 epoch, and you can see the loss. It has minimized the loss, and also the accuracy is around this much. And we have even saved the model in the model.tflun, so you can see the file will get saved here. So model metal index and all the files related to the model will saved here. So now next what we'll do, we'll just import a pickle model, import a pickle file, so that we can dump our the training data in the training binary, and we'll write it in the binary format. So for that we just import pickle and ckle pickle dot dump, and we have to specify some characteristics. So words will be words, classes will be classes, train x, train x, and train y will be train y. So let me just write the comments as well. And we even open the file of training data with the WP, so that we will even save our training data also. So for that we have used import pickle. So we have write a training data file as well with the WB, and WB you know very well in the file system. So we run this function. Now we have to restore all the data structures. So we'll do pickle.load. Again, we'll open the file, training underscore data. We'll open the file in the RB form. Words will be data, words, classes will be data classes, okay. And train x will be data train x. Similarly, train underscore y will be data train underscore y. Then we'll wrote down the comments as well. We run this statement. Okay, now we're good. Now what we'll do is, again we'll open the intents file. Open. We need to specify the destination of the intents file. So we'll just copy path and we just paste it here. So this is the JSON file. So we'll open as JSON underscore data. And now intents equals to JSON dot load JSON underscore data. Just write the comments also. This is basically loading your JSON data. Center. Now we need to, okay, now intents.json. Array, wait. Copy data. Okay, just. Okay, now it will be good to go. Okay. So now we have to load the saved model. So for that, we just have to do load and we just save. Okay, says model dot. Oh my god, the R spelling LEAR. Okay, now the model has been loaded. Now we'll clear the input. Cleaning the input. Now for cleaning the input, we'll define a function. Clean up sentence. We'll pass on the sentence. We'll define the function, and in this sentence underscore words, we'll have NLTK dot word, because we want to tokenize. The first thing we'll do is tokenize the sentence, that whatever the sentence is, tokenize sentence. Don't worry, I'll write the comments as well. Now we have to do the stemming. The first stemming, words equals to stemmer dot stem word dot lower. We have to specify the for loops for word in sentence dot words. I'll just return the sentence underscore words. Now the next function that we will define is basically return the bag of words array. That is the 0 or 1 for each word in the bag that exists in the tokenized sentence, that the clean sentence is word that we just created. So for that we just created bow, and in this we'll pass in sentence. A user will just pass a sentence words and show underscore details should be set to false, because we don't want much of that thing to be coming to mind. So clean. Now we'll call the above function. Sentence. Now we'll generate the bag of words from the sentence that the user has entered. Like the user has given a particular sentence, whatever sentence the user has given. So we'll just return we'll generate a bag of words. For that we have to do bag equals to 0 multiplied with the length of words. And now for s in sentence underscore words, for I comma w in enumerate, we'll just go to the respective words that has been returned. So if w double equals to s, then back I should be the value of 1. If show underscore details, we'll print, let's say, found in back with the percentage s sign strings and the percentage w. Finally we will return the input dot array, and we just pass on that back one. Okay, now let me just write the comments so that you are able to understand it more clear manner, in a more clear manner. Okay, so I've written the comments as well. Now let me run the code. Okay, now it has run. Now we'll add some context to the conversation so that we get a better result. So for that, we'll use context equals to empty bracket. I create a dictionary to hold users context. So we'll set error underscore threshold value to be around 0.25. And now we'll define a function def classify, which will be just going to classify the sentence. We'll pass on the results equals to model dot predict about sentence comma words, and in this value we are having 0 because we want to have to take it. Now we have to filter out the prediction below a threshold, so we'll have a results column I comma r. We'll use again for I comma r and enumerate results if r is greater than error underscore threshold value that we just created above. Now we have to sort by the strength of probability, so what that will do, just result dot sort equals to lambda function. We make use of lambda function. Reverse equals to tru true. Now we'll return score list will create, and we will create this as an empty list. Now we will run a loop for r in results return list dot append classes are 0 comma r 1, the 1th value and the 0th value. Now finally we're going to return the return list. Now the response function, one more function that we have to create is basically find the response user ID equals to 1 2 3 underscore details should be set to false. Results equals to classify sentence, and we have to if results. Now like if we have a classification, then find the matching intent tag, so that's why I've used the if results. Now we'll loop as long as there are matches to process. So if results, now inside this I'll learn a while results that till the time there are matches to process, we run this loop. So for I in intense now we'll find that. After this I'll run inside this bracket a function if I tag double equals to results, and we'll have 0 then 0th value to be returned again. That is the first entry, and we'll set the context for this. This is like in this if I tag equals double equals to result, we are finding a tag which matches the first result, and if it's so, then we'll set the context for this intent if necessary. So inside this just do if context underscore set in I if show underscore details print values. So for the show details, print function will use context, and then we have I, the value of the context index, set. Finally, we'll have context user ID set to I of value. We'll set the context set. Don't worry guys, this might looks a bit complicated, but if you go through the code very carefully, it will seems very easy for you. Now we have to check if this index is contextual and applies to this user. So for that, if not context filter, don't worry guys, I'll add the comments as well so that you are able to understand it, like in which line what is happening. Or user ID in context and context underscore filter and I. Okay, now let me just add the comments at this code. Okay, text filter, the value should be double equals to context user ID, and if it's so, then what we'll do, if show underscore details will print the respective tag to be equals to I square bracket tag. And finally, what we'll do, we'll just return print with the random dot choice. We just imported random function, if you might have noticed the starting I responses. It will select the most ideal response and it will just return. Finally, outside of this function, you want to return results dot pop. So now let me just add the comments as well so that you are able to understand it. So now you can see I've added the text well in the each statement. So you will be able to, after seeing this code, you are able to know that what this code is doing what. So I run this piece of code, get run. Now finally we have written all the piece of code that was needed to train. Now we have read it. Now in order to run the function, now let's to check, we'll just do response, function name was response, and we'll just enter sentence like let's enter hi, how are you? Hi, how are you? Now let's see what the response has been generated by the machine. See, the text says good to see you again. So you can even add response. We'll even add response, and let's say what is a resident virus. So let me just copy the resident virus definition. What is resident virus? Okay. Now when I run this, see the chatbot replies with a resident virus, a computer virus that stores itself within the memory. So this is it guys. This is how we created a basic simple chatbot, and you can even implement it on some deployment stages, like you can even deploy in various solutions, so you can like make use of your chatbot more efficiently. You can even deploy in some environment. So yeah, this was about the chatbot which was just created, and you can now play with it also. Hope you would have enjoyed the video and the tutorial. And don't worry guys, it might seem a sort of tough to you, but if you look at and if you just do it by yourself, you might find it very easy. So hope you would have enjoyed the video. Thank you, and see you in the next video.